ready to start. So this talk will be in English, but I speak also German. So if you have questions in the end, you can also ask in German. I will then translate back and forth. So how you will. So thank you very much for inviting me. The talk will be adopting the Java for the serverless world, and we will take the perspective of AWS developer because I only have experience with AWS cloud. I give this talk since I would say nearly more than 2 years, but I adopt because there are a lot of new things coming out, and that's why there will be some basics that I share always, but then there will be some also different content. So my name is Vadym, and I'm Ukrainian native, so you probably understand not very easy times for my country, but since more than 20 years I live in Bonn, and I'm one of the organizers of Java user group Bonn, but I'm also AWS community builder in the area of serverless. So I have these two passions, and that's why also this talk. So a lot of experience as Java developer, but then we migrated to AWS cloud and use serverless for mainly the new stuff. So, and of course we have very cool Java developers, but serverless is struggling with adoption or struggle. Currently, there is a light there. So that's why we'll be talking about this. I'm quite active on Twitter, but you can also find me everywhere, LinkedIn, Xing, and you can also drop me the email. So yeah, I'm working for the company called IP Labs. We are based in Bonn. We are 100% subsidiary of Fujifilm Europe, based in Düsseldorf. So we offer the software for creating and designing of photo products like calendars, photo book of the year. You can order prints, so everything dealing with photos. Started in the data center, but we closed all 2 major data centers this year, so we are completely AWS native, at AWS, but partially native. So that's why also lots of experiences in the last 5 years of migration. So now let's start with the talk itself, and we will just to set the scene, we'll start with the Java language popularity. And if you see this red monk page over the years, then you see that Java was always among one of top 3 popular programming languages. Yeah, the same is true also for this year. You also see Java is somewhere in the top of the corner with JavaScript, Python, depending on how the statistics are gathered, GitHub repositories, job postings, Stack Overflow questions, and so on. There will be some changes, but nevertheless, Java is a very popular programming language with a very strong JVM and community behind this. This is what really shines. Now we will look into AWS and serverless itself, and no surprise, AWS is leader as a cloud provider. Depending on the quadrant, there are different like infrastructure, code, platform as a service. There may be variations, but nevertheless, this is nearly the same picture. You have these big 3 cloud providers, and in the challengers, you won't see anything currently. They are quite above everything else, and AWS will be #1 in most categories because they simply started earlier and just eat the market. Now, if we will look into organization that adopt serverless, then you will also see that many organizations adopt serverless to one or other way, depending on the meaning of the serverless, because everyone uses the S3 service, like the packet storage, and it's also serverless. So depending on the context, but you see that adoption of serverless in AWS is even better than other cloud providers, which also means that the services are mature. If you also look into the adoption of Lambda, which is in the heart of the serverless applications in AWS, where you write your business logic, it's quite an old report, but that you see that Lambda invocations increased over the years, 3.5 more times than it's been previously, and probably it's even more increasing currently. Now, if we will look into the life of the Java serverless developer in AWS, you will find this picture. It's not surprisingly that Java 8 is supported for serverless services with even extended long-term support. AWS offers Amazon Corretto. This is the Amazon solution or offering similar to adopt OpenJDK and so on, and they will even support Java 8 until 2026. For good or bad, it's your decision to stay with this so long, but they patch all the security and performance improvements from the Oracle itself, and then it's given for free. mainly, and Java 11 will be supported by since 2019, and Amazon Corretto says they only will support long-term versions. But currently no Java 17 is supported for Lambda, so you cannot select manage runtime Java 17. There are only Java 11 and 8, which is quite disappointing because Java 19 was released yesterday, so we are 1 year after releasing of Java 17 and still no support for Lambda. I hoped that it will change until this presentation, but it's not the case. So if we will look into the Java as a programming language, we know that it's very fast, mature programming language, but the serverless adoption will look like this. Yeah, this is the picture from the last year, and you see that the programming language Java is just used in 5% of cases, and you see Python and Node.js quite above for serverless solutions. Now, this report this year came where they ask different questions. So the percentage of organization using these programming languages in the serverless world. So the picture says the same, only because the Java is used in 14% or nearly 14% of use cases doesn't mean that these are kind of very hot applications, that maybe some tooling and something like this. So you see that it's mainly the same picture. Java is quite behind Python, Node.js, or other JavaScript derivatives. So it's still the situation that the community of Java cannot embrace serverless. I think it doesn't depend on the cloud provider, still the same picture. So generally, developers who love Java will be happy to use serverless, but what are the challenges? And there are mainly two ones that we will cover. These are cold starts, which then also means latencies. But there's also memory footprint, which also leads to the higher cost in AWS, and cost is always a factor. But before we start with these two, I would like just to go over AWS Lambda basics, so you understand how to write Lambda function and so on, and then some basics behind this. So if you would like to create Java function with Java Lambda function, first of all, you should give the name of that function and then select the manage runtime. So you see there is Java 11, but there is also Java 8. There is also memory, architecture that you can choose since 1 year. So default was x86, but now you can use select ARM 64, and then simply you also have to select the memory. So you cannot select CPU, you select the memory configuration of the function between 128 megabytes and then 10 gigabytes. And then you need to know that you will only get the CPU, the full CPU, if you select something like 1.8 gigabyte of memory. So if you select only half of the gigabyte, you will get the fraction 1/4 of the CPU. It's very important to understand. So with 10 gigabytes, you have maximal 6 CPUs, but it doesn't make any sense to select more than 1.8 gigabytes if you cannot deal with multiple cores. So if you cannot process in parallel something, then you simply lose money. And yeah, you can also give the timeout. Default is, I think, 30 seconds, and you can select the value between several seconds and 15 minutes, depending on your use case, is the public-facing application or not. So now you have mainly two possibilities to write the business logic. There are more, but these two are most popular. On the left side, you see you're implementing request handler interface from the Amazon SDK, Java SDK. Yeah, and then that's simply one method to implement handle request with the response request, and then it gives response back. And then you have this context, which also comes from AWS SDK. And on the right side, you see that there is no dependency to AWS SDK. This is, we implement purely function interface from Java 8 with the only method apply there, so no context. It's a matter of your choice. I personally prefer the first one because this context gives me the logger, so the logger is automatically injected, and sometimes it's kind of debugging if you can call this get remaining time in millis. If you run into the timeout, then you would like to see very quickly what part of the application spends the most time. And sometimes it's very easy to call this. But this is mainly matter of taste, how you deal with this. You can choose both. So now we will look into the AWS price model. And there are simply mainly two dimensions, request dimension and duration memory dimension. So request dimension is very simple. You simply pay 1 million of Lambda invocation $20. Yeah, it doesn't depend on the programming language. It depends simply on the architecture of your application. Duration memory tier is a bit of complex. It depends on the architecture, the amount of you pay. And this is amount that you pay if you select gigabyte of memory and your function runs for 1 second. Yeah. So in case you select only half of the gigabyte memory and the function runs for 1 second, you will pay only the half. Yeah. Or you select 1 gigabyte and the function takes half of the second, you also pay only the half. So this is kind of equation. And this is the simple calculation. You have 1 million requests. You have selected the Lambda with this architecture and give the Lambda half of the gigabyte of memory. And we will assume each Lambda invocation from million takes 200 milliseconds, which is not the case, but for the simplicity, this will be amount that you should pay. This is the request tier. This will be the duration memory tier. So now we covered the basics of pricing and how to create the function. Let's look into this challenge number 1. This is so-called cold start. In order to understand this, we need to dive deeper into life cycle of the functions. Yeah, it's a bit different if you work with the containers. So imagine you deploy your function for the first time. Yeah, normally you push your code somewhere and it's then S3 bucket. And then if the function should run for the first time, the execution environment need to download your code and then start this execution environment. So JavaVM and so on. And then all static initializer block need to run for your function and initialize everything recursively. So you probably load the classes and then they also need to be loaded and their static initializer blocks need to be instantiated and so on. And only then this method apply or handle request will be called. This is the handler code execution. And only the last piece is the warm start, and all other 3 are the cold starts. So this is mainly the same explained. So by starting new execution environment, the Firecracker VM will be started. This is the container orchestration solution from AWS. Yeah, similar to Kubernetes, but they have their own solution. This Firecracker VM will be started, and then the initializer block will load the static initializer block of your function. What is very important, that only for the static initializer block, you will receive the full CPU access up to for 10 seconds for free. That's very important. It won't be built, and after 10 seconds, you will receive timeout. So you cannot call this static initializer block more than for 10 seconds. That's kind of limitation, but it's very important. If you give your function only half of the gigabyte of memory, you will only have the quarter of the CPU for the handler method, but for the static initializer block, you will receive the full CPU, so you can boost. That's the important message. Yeah, and in the end, then the static initializer block will be called. So this is I would say the full picture, full life cycle of the cold start. So the situation is if your request come in for Lambda, and remember the function, the one container can only run one function in parallel. It's not like the containers that they run multiple requests until they cannot scale. So one container can only run one function in parallel. So in case that there are warm containers, then this warm container will be assigned to you, and then you can execute this handler method. But imagine you are calling the function for the first time, you wrote this or updated this, then there are no containers. So the container needs to be started, and this is then this cold execution path with the download the code and so on. And the same may be true if you have 2 warm containers, but now you have 5 requests in parallel, and then 2 warm containers serve these 2 requests, and another 3. Then 3 containers need to start, and then you have cold start for 3 containers. And also, this is the case. Amazon doesn't release how often they release the containers for security reasons, but the people find out that something between 1 and 2 hours, the containers will be released anyway. Yeah, so even if they are warm, even they will be used, Amazon will release. So it's not the case that the container will stay warm forever. So you experience this cold starts anyway for some percentage of the cases. So now we will look into what does it mean for Java application to have this cold start. And then people measured this, and then you see for the Java application, which is nearly empty, doing nothing, simply calling the empty or hello world handler method, you just see that it may take up to 1 second without any logic, without any dependencies. And then you see that JavaScript and Python have both lower cold start. That's also one of the reasons. But of course, nobody writes empty Java functions, and this is it may increase significantly in case you are using other AWS services. You are typically connecting to the DynamoDB or using simple notification service, simple QA service, or third-party components on the outside of the world. And we will see what are the factors why this increased, and we will look into the artifact size first of our application. It was measured. It's very difficult to understand, but generally what this picture says, that with the larger artifact size, large zip or large Uber jar, you will have bigger cold starts generally with Java. And doesn't matter currently if it's Java 8 or Java 11, they are kind of equal. As there, we hope that there will be improvements with Java 17, but the runtime version is currently not the factor, but the jar size, of course, because you need to download the code, you need probably to initialize the stuff and so on. It contributes a lot. So we will look into the best practices, how to minimize this. So my first naive, I would say, Java Lambda function with DynamoDB behind it, the cold start took something between 10 and 20 seconds. And if you experience this even with 1 of 1,000 requests, then probably you will lose these customers, because nobody would like to wait 20 seconds in the public-facing application. At least if you can process asynchronously, or this is tooling, this is something different, but generally without considering best practices, it may hurt you. So now we will look in these best practices, and one of these is since years there is the old SDK Java version 1.0, but since years there is also newer 2.0, and you should update anyway. It has lower footprint and it is more modular, but it also allows you to plug in HTTP client of your choice. And AWS has its own asynchronous AWS common runtime, because what you see here, that with standard HTTP URL connection client, or even third-party Apache or native, you will have also very heavy cold starts. And this is logical, because all these other HTTP clients, they cache a lot. They are for the server-side application. They are not designed for short-living functions. There, the cache doesn't matter a lot. You need simple, quick execution. So the AWS async HTTP client also is one of this improvement. That one is that with SDK 2.0, you can fine granular define your dependencies. So if you only use DynamoDB, then you can only specify this. So for the Java SDK 1.0, all services were packed together, and currently there are probably more than 300 in the SDK, and you probably only use 3 to 5 in your function, even if 3. And of course, it just you deal with a huge artifact size and probably all that stuff coming in. So only specify dependencies for what you use. And of course, it's always the best practice if you just set the scope test for like JUnit stuff and so on. You don't need this in your artifact when you deploy. So other best practices, totally logical, use this static initializer block of your Lambda function. Yeah, once again, take advantage of full CPU access for free for 10 seconds. And for example, if you would like to initialize DynamoDB client, do this stuff in the static initializer block and not in the handle request method itself. You will just boost with this and it will be much quicker. Also, if you are building clients, Amazon clients like DynamoDB, SNS, SQS, and so on, then you may not specify the region and credentials. And AWS is capable of finding out where you deploy your application, where the Lambda function is running, and also find out with credential chain, which is similar to the filter chain in the Java world, where you store your credentials. But it takes time. It can take seconds. But you perfectly know what the region you use, and also where you store your credentials if you store them. So specify that stuff also when building the client that you are using. You will also save seconds. Another optimization which is kind of interesting is also that you only use tiered compilation. And tiered compilation, so people who know Java know that there are two phases of compilation: client tier 1 and server tier 2. And tier 2 is just-in-time compilation. Then, yeah, kind of after 10,000 of invocation, there will be kind of optimizations kicking in, but not every function survive 1,000 or 10,000 invocation that this optimization will bring you something very, so will bring you something. And also this just-in-time compile optimization, they also cost CPU and memory and thread doing the stuff, optimizing that stuff. So for the serverless application, for short-living functions, it's sometimes really better to say stop at the tiered compilation level 1. So only use level 1 and then stop, and then you free your resources for the function, and also may optimize your startup time up to 60%. So this is one of the, I think, most important optimization. You see all around resources where you can read about this. But generally, best practice will be avoid reflection, runtime, bytecode generation, proxies, dynamic loading, and so on. So all that stuff that takes time, that takes memory, takes CPU. And of course, for example, Spring developer or Juice developer will say, how can I do this? Because these are how the frameworks are currently implementing. They are for the serverless world. So we will look into this to the other frameworks, but generally reflection-based frameworks should be avoided. Now we will go into the cost optimization part. So once again, we have request tier. So we have request duration, which is not dependent on the programming language, and we have duration memory tier. And generally, that's the case. If you double the memory, then generally your cost will be doubled. But the question is, with doubling of the memory, you will also get the CPU doubled. And with more CPU, you can be quicker. And also duration is also a cost factor. So the question is, what's the best memory configuration for the function? And one of the tools which can answer this question is Lambda Power Tuning, which is open source and coming from AWS world itself. It uses step function workflow to test your assumptions. So you give the memory configuration for your function, and then this tool will run your function with all this memory configuration and will give you the best suggestion. And this is, for example, one of the outputs that you see the execution time and cost, and this is the memory. So you see that this is the sweet spot with 1 GB. You have the best memory price, price relationship, because if you give more memory, then the duration of the function won't decrease anymore that significantly, but the price will go up. So this is the quick sweet spot of this. And so this is a quite useful tool. It's currently much more complicated because previously it was only one architecture, x86. Now you can also select ARM architecture and test what's the best price performance for 2 architectures, and then also select architecture, because ARM architecture is 20% cheaper for the memory configuration. So this is also one of the tools which can answer these questions. But generally, Java is well optimized for long-running server application, high startup times, high memory utilization. And with all this optimization applied, we will see the statistic. We will still deal with seconds of the cold start, so maybe 5 to 7 seconds, depending on the situation, depending on your application. But you cannot go any further down without considering other things. And that's why GraalVM enters the scene. And it's not to talk about GraalVM, probably everybody knows what it is, and so on. Important to know that there are editions, Community Edition and Enterprise Edition. Enterprise Edition will cost you money. I think only on Oracle Cloud, it's for free. They give you some performance boost for this, but also Community Edition is very good, but also they only support long-term Java versions 11 and 17, as you see here, so nothing for Java 15 and so on. What is very interesting, and only what we will take into the consideration, this is the substrate VM tile part of the GraalVM architecture, which is optional. So you can decide if you use substrate VM or not. And this substrate VM gives you the ahead of time compilation. Yeah, and the ahead of time compilation works like this. This is static closed world analysis. So all reachable methods, fields, and classes will be gathered and packed. Only what is used, and then the native code will be produced. So native code for your operation system, maybe Linux, even Windows and Mac are both supported. So what advantages does this ahead of time compilation, and especially native image, gives you? First of all, just native executables, you have only very small cold starts because everything is pre-initialized. You can even pre-initialize static blocks in some cases, and native images uses less memory. And this is all this criteria for the serverless application just to be selected. So this is kind of, would say, the good stuff. But the challenge is that AWS doesn't provide GraalVM native image as a runtime. You can select Java 8 level, but you cannot select GraalVM. You cannot select GraalVM native image. Yeah, native image is just upon GraalVM. So, but there is AWS custom runtime option. You can select this runtime option, yeah, as a managed environment. And then there is a possibility. So this runtime option gives you you can deploy a Linux native image on this. So you should call your function, so you should zip the function and call it function, yeah, function.zip, and then the native image should be called bootstrap. And then the AWS custom runtime environment may initialize this native image, but only Linux image. That's very important. So generally, GraalVM gives you the choice between just-in-time compilation and IoT compilation. You should decide. And of course, everything is a trade-off. So for the just-in-time compilation, it's optimized for the peak throughput and for the maximal latency. So this is the properties of the long-lived server application, and ahead-of-time compilation is optimized for start speed time, low memory footprint, and also small packaging. Yeah, these are the properties of the serverless application. But of course, building the AOT native image takes time. So on my machine, I experience between 3 and 4 minutes. So this, you have to take this into consideration. It's about developer experience and the speed and so on. So now let's look at the statistic. What does it bring us? Yeah, how to compare. Now we have some kind of typical Java serverless application. This is the link below where I got the statistic, but I have the same. And then I tested. You have API gateway for just accepting HTTP request, Lambda function, or the functions in the middle which talk to the NoSQL DynamoDB. And then just you see that this blue one, these are call starts for this simple application which are optimized with the all best practices. So simple Java runtime, you have, depending on your memory, between 6 and then 2.5 seconds of the call start. So you cannot start Java application with 28 megabytes, so it runs out of memory, so you need quarter of gigabyte at least. And with orange one, you see this GraalVM native image statistics, and then you see that it's always below 1 second, and it's even half of the second for 1 gigabyte of memory. And you see this with the GraalVM native image, their numbers are quite comparable to Python and Node.js cold starts. So we are not far away. We are not 100 milliseconds is nothing, but 6.5 seconds, 5 seconds, it still hurts you a lot. So GraalVM optimizes this and optimizes this heavily. But generally, people love frameworks. Yeah, we're using Spring, many of you for sure, and it has the reason. So people would like to use that abstraction to become more productive. And of course, also in this world, the frameworks were developed to help with the productivity, but also address these challenges of serverless application, but also microservices application need to start quickly, and then you scale out, and then the servers go away, and so on. So these are the same stuff. So this, Quarkus and Micronaut, but also Spring Native, they have kind of same characteristics. They rely on as little reflection as possible. They avoid runtime, code generation, all these proxies, dynamic loading. They try to process annotation at compile time, which means, the compile time takes longer, but then the runtime will be much better. They help common goals at best increase developer productivity. They even may decrease the cold starts, because at least Micronaut is doing some magic to optimize even further what Java cannot optimize, and so on. So we will go through some examples of this application. So the people who didn't use Micronaut, Quarkus, and Spring Native, it will be very short journey about this. Sorry for being too quick, because I want to show you several examples. But generally, you can build this stuff with all three frameworks. You need GraalVM and native image installed. You can use Maven or Gradle. All frameworks now support them, and use the AWS SAM, serverless application model, but you can use CloudFormation, you can use a serverless framework, or other stuff. It doesn't matter, but the examples will be using serverless application model. In the end, Linux executable will be built for the GraalVM native image, and then, this native image will be renamed in function and will be zipped, and then deployed as a AWS custom runtime. So we first start with Quarkus, and this comes from Red Hat and IBM world. They call this Kubernetes native framework. I don't understand why this Kubernetes native if it runs on AWS Lambda. So for me, it's a general purpose framework for building microservices and serverless applications. And what is really cool, it also supports Spring annotation. So this is the example of Lambda function, which is designed like Spring application. So you see REST controller, you see request mapping, all that stuff that we know from the Spring world, and all the magic happens in XML or in Gradle. You see that we have native image goal, and we can build this native image with profile native. And this is the code for zipping. So I define that the name is function, and then it will be zipped. And all the dependencies, how the Spring annotations are converted to Quarkus annotations, and how the Lambda itself will be proxied is in these two dependencies: Quarkus Amazon Lambda and Quarkus Spring Web. These are this annotation processor. And in the end, it takes, as I told you, 3 to 4 seconds, and then the native image will be built and deployed. And now this is kind of SAML template, just to deploy infrastructure as code. So you see here, this is the function zip. This is the native image, which will be in the target folder after running the Maven. I say runtime is provided. Handler is not used. It will automatically determined. And I also need API gateway, which will be the URL will be generated if you first deploy the template with SAML deploy. And in the end, you will see the output of the API gateway HTTP URL. And then this is kind of pet application. Then you have this stage production, because I use production stage. And then with pets 5, you can just retrieve the information for doc with ID 5. So this is kind of, we will see this template much quite on the applications that we built, the same stuff. This just the function, Lambda function, and then API gateway for fraud door. So Quarkus has additional features which are quite useful. It not only works with Spring annotations, but it also supports the request handler interface implementation from AWS itself the same way, but it doesn't work with Java 8 function interface. Currently, I run into error. It uses websites, so you can go into the Quarkus code, Quarkus IO, and simply doing the same stuff as Spring initializer, pulling your dependencies, and then the project will be generated with POM and Gradle itself. You can also use CLI for creating applications. So just dealing with Quarkus creates, so the scaffolding stuff. And you can use Quarkus Amazon Lambda extension in POM XML, but you can easily switch to, for example, Azure extension. Yeah, you write the code like Spring with Spring annotation, and then only using another extension, the stuff will be generated for you to be deployable in other cloud provider. You can also select, you can build the native image itself of the Lambda, but you can also use container. Yeah, and then in container, everything will be installed, and Docker container native image will be built. It has the advantage that you isolate the environment with Docker. It's very useful if you are working locally, that nothing, so that you probably have your own dependencies. With Docker, you have this isolation. So you can use both depending on the context. So very, very cool. And Quarkus supports Eclipse microprofile. That's the important stuff, and also funky for multi-cloud, but it's outside of today's scope. So Micronaut is kind of the competitor. It comes more from the, I would say, Oracle and even AWS world, because several people, at least one person working for AWS, is in the advisory board of Micronaut, and the inventor is Graham Rocher, who is perfectly known for also Groovy and Grails and so on. And he joins Oracle, so I assume that the Oracle will support that. And they go another way, so they don't support Eclipse microprofile and support their own annotations. Nevertheless, it looks the same. You see this controller, post, get, and so on, but all annotations, which we are quite familiar, come from the Micronaut package itself. And this is the same stuff with all the frameworks. Behind the scenes in POM XML, you have these dependencies to Micronaut function, AWS API proxy, even API gateway proxy can be generated. And this is Micronaut function, AWS custom runtime to build all this native image of Lambda. The same is here. You can build the native image, but you can also build the Docker image itself, pure Docker image or Docker native image, yeah, to isolate your environment and then provide the native image of Docker, which then consists your Lambda. So the same stuff, also the same, where I see they should potentially support Spring annotations, but this example didn't work for me. So I only got it right with Micronaut own annotations, but they advertised they supported the same stuff. You can use CLI or website for creating the application, for pulling your dependencies. They support custom validators. They have no support for micro profiling, but they support Micronaut IoT for further optimization. I have slides for that, but I will go over. But you can discover it's also just decreasing the cold start. So the last one is kind of Spring Boot framework or Spring applications, and of course they started, yeah, with all that stuff with reflection and so on, and of course they would like to embrace the community, and they started this GraalVM native project, but it should be released this fall, then for Spring Boot 3 and Spring Boot Framework 6. But of course, they had to redesign a lot on the ground to make it work. That's why they started kind of earlier and had more to do. Yeah, starting from scratch like Quarkus and Micronaut is always easier, but this is the same stuff that they support. So you can use Spring Boot application just with the functions, and mainly it's the same stuff. How you do this? So you simply match here. This is the functions where I match to this stuff which implements API proxy request, because all the requests in my examples will come from API gateway, and then I can retrieve these parameters, and then here what I'm doing, calling my Lambda function, and then retrieving the response. So also very, very cool. This is same template, how I match the function in the same template to the function in the Java code. This is done by name, and yeah, and then this will be matched here, and because I have here this ID parameter and book and so on, so this all matching by convention. And then if I deploy the same template, then the same stuff happens. API gateway will be URL will be generated, and then I can call book under slash book by ID. Yeah, this is kind of this method, and I can have get books and so on mapped to different functions within the same class. So I can define another function and then map to another Lambda function and so on. Also very flexible. The same stuff here. Yeah, you see they also support native profile and all this stuff for generating these lambdas and these three dependencies: Spring Native function adopt AWS, and also Spring Cloud Functions Web that I can use the annotations. So the funny part is that I only got it to work with request handler interface from AWS, and Spring Native currently from my last test doesn't support their own Spring Boot annotations like REST controller, REST mapping, and so on, which Quarkus and Micronaut do, and they also doesn't support Java 8 interface as well. So it's only working with the request handler, which is not bad. We only need one way of working. So these are another statistic how the people compared all these three frameworks, Spring Boot native. Of course, in the first comparison, you see this is for simple Java runtime, without GraalVM, without native image. Yeah, but it's not plain Java. So using all the three frameworks, you see that the call starts vary depending on memory and so on, but they are quite significant. Yeah, especially with Spring. Now the same code was tested with GraalVM native image. It's important, and then you see that the call starts are currently with these frameworks. Yeah, something. Yeah, half of the second. It also my observation that Quarkus provides the lower call start, and then Micronaut is a bit behind, and Spring Boot is just not far behind of Micronaut. Last year, as I tested the same stuff with Spring Boot, they had call starts more than 1 second. So they improved a lot only within the last year. So now we talked about GraalVM native image. We saw that GraalVM native image reduces the call start, and then the frameworks give you productivity. But there is another possibility to deploy Lambda function. It's just by using the container. So you can use Docker container without GraalVM, so simply Docker container. It's simply another possibility, and it gives you the possibility to use the recent Java version, yeah, like 19, because Coretta will support only long-term version. Oracle GraalVM supports only long-term version. Sometimes there are 6 versions or even 8 versions behind, because yeah, currently we have Java 11, for example, for Lambda, and Java 19 has been released, and we are missing the features. So if you say the new features make me productive and I'm willing to take, yeah, more, yeah, it can be costly because I don't use GraalVM native image. It's also your choice, because I will come back, because it gives you more possibilities. You have these tools, JDepth and JLink, and it gives you the possibility to build the runtime that only includes what you need. So if you don't use XML parsers, I don't know, data sources, that you can probably exclude this, and then the package will be kind of much less, and then that also gives you the boost of the cold start. You can also use this feature class data sharing to improve the stuff. So all that is given if you use some particular version. It won't be probably possible with pure Lambda solution. So now the conclusion before we wrap up. So generally, or the recommendations will also follow. GraalVM and frameworks are really powerful with a lot of potential. So GraalVM native image improves cold starts and memory footprint significantly. We saw this just, yeah, below, so something, yeah, half of the second. But GraalVM is currently not without challenges. So AWS Lambda custom runtime requires Linux executable. So people using Windows and Mac, they need to think how to build this if we do something locally. Also, building custom runtime requires some additional effort. You need to scale these pipelines, and they require 6 to 10 gigabytes of memory currently, and take 3 to 4 minutes to build one function. Now imagine you have 10 functions, 100 functions, you change them a lot, so you need to scale your CI pipeline. It's not an easy stuff. And the build time is also a factor here, yeah? And yeah, you pay for the init phase of the function packaged with AWS custom runtime and Docker runtime. Yeah, for the managed runtime, Java 8 and 11, it's for free, but init phase will be built for custom runtime and Docker runtime. So my personal recommendations, they are really highly opinionated, but still, by default, use the plain managed Java version. Yeah, start with this. Use Corretto 11, then 17, you can probably use Micronaut for Quarkus and other stuff like framework, even with the plain functions. And yeah, if you don't want to miss the innovation, years of innovation, then you can use Lambda Docker container image support. But if your function really needs constantly low response time for the known period of time, for example, at 9 o'clock in the evening, you sent a lot of newsletters, then you have the functionality like provision concurrency. They are the warm containers, will be pre-provisioned for you for some specific time frame, but you pay for them even if you don't use. But you need to know how much. That's another story. Yeah. But in case, of course, if you have function that needs constantly low response times and low costs requirement, and you don't know for what, so the scaling is not predictable, then you have to use GraalVM native image with optionally your favorites framework and AWS Lambda runtime. That's currently the only solution. Yeah, and some frameworks even, yeah, they improve your productivity, but may add up additional cost because these frameworks may add up to build time and so on. So you have to figure out. Probably people hear about the crack for Java. That may be something coming up. And probably there are talks about this. Not sure how AWS will support this or not, but this may be an alternative to GraalVM native image, Java on crack. So, and with this, you have a lot of links there you can try out yourself, even with your frameworks. And with this, I would say thank you very much for listening. I hope you enjoyed this, and we have several minutes for questions, I think. So now we'll go into the chat. I don't know if that will be moderated. So Stefan, thanks for the feedback. So what questions do you have? Okay, can we deploy all type of Java applications on serverless? The question of what do you mean by all type? So you need small functions, yeah. So machine learning and big data may be the use cases that are not very well supported with the Lambda functions, but generally web applications, most of them are a very good fit for this. So another question, you talked about static initializer being executed in the cold start. What about the constructor of the handler? So I think the constructor is not part of the static initializer block. So generally, there should be at least no logic in the constructor. So how I write Lambda functions, there's the logic in the static initializer block, and then there's the logic in the handler function itself. Yeah, so I cannot initialize stuff because the Lambda functions will be called by some event, like API gateway request or SQS queue is dropped. So there is nothing to do with the constructor. So what's the difference between AWS custom runtime and Corretto JVM? So custom runtime, you deploy like native image, and with the Corretto JVM, you simply deploy a Java application. Yeah, you package your function like a jar, and in the template, you say, where is your handler function? Yeah, in what package, what is the class name? And this is normal deployment. And custom runtime is usually kind of native image, or you can use custom runtime to deploy, for example, there are PHP custom runtimes, yeah, something that is also not supported as managed runtime. The people build stuff with that, like Flutter and so on. So this is also one of the usages. But I personally only use this as a native image. So I hope I responded to your question. Yeah, thanks. Thank you too, Ramin.
Bye.